And welcome back, students, to another lesson of Algebra 2, where today we're looking at the behavior of graphs of polynomials. Now, whenever we graph a polynomial that's already given to us in factored form, we only need to know a couple of things, and then we're going to be golden the whole time. Now, we don't need to be super precise about where we put each piece of the function, so we're only going off the rough shape of the function based on factors that are available to us immediately. So one thing we know from the factors are the roots. So the roots are going to be the things that make the polynomial equal to 0, and that is given by showing what makes each of the pieces 0. So here, x squared is going to be 0 whenever x is 0. 2x minus 4 will be 0 when x is 2. X plus 5 will be 0 when x is negative 5. So our roots are going to be at 0, 2, and negative 5. And the way that we are going to find the graph of our polynomial is by checking its degree, which is going to be the sum of the exponents of all the x values. So 2, 4, 5. So that means it's going to start one direction and end the other direction. So it's going to be like an odd function, except for it doesn't have to be as symmetrical as all that. But it means it's going to start negative and end positive, unless the leading coefficient had a negative sign, in which case it would start positive and then negative. But here, we know it's going to start at 0, and here's what we can tell based on the exponents of each factor. The exponent of each individual factor is going to determine whether or not the function bounces at that point, meaning it starts negative and stays negative, or starts positive and stays positive, or vice versa. Or if it starts positive and crosses the x-axis, or it starts negative and crosses the x-axis into positive. So what we are going to do is, all we need is to find the leading term first. That's going to be 4x to the 5th, because it's going to be 4x squared, another x squared, so 4x to the 4th, 4x to the 5th. And when you get super duper negative, you're going to start negative. Now here, we see x plus 5 has only one factor, so it's going to cross. If it's odd, it crosses. If it's even, it bounces. Now it gets to 0. X is actually used twice, so that's actually going to bounce when we get to 0. And then 2x squared minus 4 is also used twice, so it's going to bounce again when we get to 2. So if it were used 3 times or 5 times or any odd number of times, it would cross. If it's used an even number of times, it bounces. So now let's go on to the next root, or the next equation. So x minus 2, x plus 4 squared, x minus 1 to the 6th. All we need to know is find the roots. That'll be 0 at x is 2. This will be 0 at x is negative 4. This will be 0 at x is 1. And let's just go ahead and plot 1, 2, negative 4. Now we have 9 uses of x, because 6 from here, 2 from here, 1 from here. Remember, when an exponent isn't written, we assume that it's 1. So we have 9 if we add up the 1, 2, and 6. That means it's going to start positive and end negative, or start negative and end positive. Since the coefficient of the leading term, if you multiply this all out, let's just show that you get x minus 2. The x term is going to stay positive, or the x to the 9th term, that is. So it'll start down here, and it'll end up here. Now in between, we need to figure out what it does. So at x plus 4, so the minus 4 place on the x-axis, it is going to bounce because it is even. At x minus 1, or when x equals 1, it's going to bounce again. And right here, finally, oh, I've actually made a mistake. It's going to bounce this way because it's supposed to bounce at -4. It's supposed to bounce at 1, and it's supposed to cross at 2. Because here it's even, here it's even, and here it's odd because it's only used once. So it goes cross here, bounce here, and bounce here. So now let's go to another problem. I'm going to do 5 of these. I'm going to ask you to copy those 5 and then to do 6 and 7 on your own. And I want you to mark down specifically, show where it crosses and where it bounces and what directions they need to go in their behavior. So here, find the roots. Show me the roots first. So that's 4, that's -5, that's -3. So we're going to plot those here. That's -3, -5. This is used 6 times because 2 plus 1 plus 3 is 6. And I circled nothing a moment ago, but that's because you assume that the missing exponent is 1. And what we're going to do with that is we show that since the x to the 6th term, if you expand it out, would be positive, we are going to go ahead and show that it ends, that it starts positive and it ends positive. And it's going to cross at -5, and it's going to cross at -3, and it's going to bounce at 4, because at x plus 5 has multiplicity, meaning it is only a factor, once. X plus 3 has multiplicity 3, meaning it is a factor 3 times, at which point it crosses. And x minus 4 has multiplicity 2, so it bounces because that's even. So we want to say the root here, again, like we've been doing, 5, -3 will be a root here, 5. So we know it's going to have 1 plus 2 plus 3 is 6. So it's going to either start positive, end positive, or start negative, end negative. And if we expand it, then the x to the 6th term is positive. So we're going to put the roots at 5 and -3 and show that it starts positive and ends positive. In the meantime, though, we see that x minus 5 would appear to have a multiplicity of 2, so it'll bounce. X plus 3 has a multiplicity of, that's not making a ton of sense to us. Why is it supposed to cross here, but it bounces there? So if you pay close attention, x minus 5 squared and x minus 5 both show up in this factorization of this problem. So we can actually combine those into x minus 5 cubed. So really, that's the same as having multiplicity 3 here instead of 2 here and 1 there. So now that means it's going to cross here, and we already knew it was going to cross there. So it's just going to be a nice little smiling one, and we're not going to have too much trouble with it. So problem 5. This one we have a negative sign out in front. So this is going to change things a little bit. We're going to find the roots again, as usual. So -5, -1, and 1. So those are our roots. We now need, again, let's go ahead and check the multiplicity. 2, 3, 1. We're going to go ahead and show that that is going to end the same way it starts. The x to the 6th term is going to be positive if you expand this out, but since we have a negative sign on the end here, it's going to start and end negative. So we know it's going to start here and end here somehow or other. That means that since the multiplicity here is 2, it bounces. Since the multiplicity here is 3, which is odd, it crosses. And down here, the multiplicity is 1, which is odd. It crosses. So what I want you to do is copy down all of these and make very clear at which roots it bounces and at which roots it crosses. So for each of these, write down the expression like so, and then write the roots underneath, and then label each of the roots, and just like this, write bounce when it bounces, cross when it crosses, and the arrows should tell me well enough if it needs to go up or go down. So I'll go back and write it on like one more of these, but I'll trust you to write this. It should be pretty self-explanatory, but just to make it clear where it crosses and where it bounces, because they're even and odd. So these last two problems you are going to do on your own, and you're going to turn them in the same way. So you're going to write all this stuff down, take a picture of it, and submit it to Google Classroom. So thank you all for watching the video, and I will see y'all next time.